Okay, everybody. So I didn't get to all of the problems. There's a few left. I'm making this video here, and I'm going to give it to all periods. So there's a question that asks you about the surface. You're going to be asked to find the surface area of a sphere. Surface area of a sphere in terms of pi. It means we leave pi alone, and it's going to be a part of our answer in terms of the symbol. So when I look at the surface area of a sphere, the formula says it is equal to 4 times pi r squared. Well, let's go ahead and make up a radius here. So if we have a radius of 8, for example, we would just go ahead and substitute it in here. So this is a radius. So subbing in for our radius, let's say 4 times pi times 8 squared. Well, 8 squared is 64. And then 4 times 64. Okay, so we're going to go ahead and take a decimals out here, like this. Make sure you have your decimals tomorrow. Oh, that shouldn't happen. Decimals like this. Make sure you have your decimals tomorrow. Settings, especially for the trigonometry and those angles of depression, set to degrees. First thing you should do. So now we're going to go ahead and take this question, and it says 4 times 64. So I'll say 4 times 64, and I get 256. Now notice I did not operate with pi because pi needs to be part of the answer choice. So 256, pi is what I'm left with. Remember, this is surface area, so maybe this is in centimeters, so I would say centimeters squared. So the surface area of this particular sphere would be as follows. Okay, let's go ahead and move on to the next one here. We talked about this in class. The big thing here is if you're given a, for example, if you're given, let's say you're given something like this here, okay? And then embedded in here is another trapezoid. So you have one trapezoid kind of overlapping the other. The best thing to do, just the way it says here, is to go ahead and separate the two. You have one big one and one small one. This will make it much easier to identify the corresponding parts, whether they be angles or sides, between the two images. So make sure you go ahead and do this whenever you see overlapping figures. Next one. In a survey, we'll come back to this one in a second here. Altitudes and triangles create two similar triangles. So I think we touched on this in class, but basically watch as follows. I'm going to make one big right triangle, just like this. Now, if I take an altitude as follows, and I draw it from a vertex to the opposite side, an altitude automatically makes another 90 degree. So, because this is created here, this altitude now creates two similar triangles. I have the big one, and I have the baby one, like this. And we talked about this in class, and they both have 90 degrees here. So let's think about this. Let's say the big triangle before I put the altitude there is A, B, and C. Okay, and let's say this little altitude, this point right here can be, we'll make it H. Now, A here is in reference to the large triangles 90 degree. B will be up here, and C would be here. Now, when I'm go ahead and identifying the smaller triangle, kind of embedded here, look at where the right angle is here. It's at H. So my H will go there. It goes up to A, right? The tiny point up here will be A. And then, of course, by default, there's C. Notice that C here and C here are congruent. In fact, they're the exact same angle. So make sure that you separate your overlapping or embedded figures. It'll make it much easier to identify corresponding parts or the corresponding geometric parts of these two triangles before comparing. Let's go through another one. An isosceles triangle congruency. Be aware that an isosceles triangle, right, has two sides that are equal or congruent sides, which means if this side AB here and this side AC are equal, then the parts, the opposite angles must also be equal, right? So here and here, that means that angle B here, angle B equals angle C, okay? Or they're congruent. So when you're trying to justify parts of a triangle, remember that this is the case. Let's go ahead and move on. Oh, and at some point you may need to draw, let's take this line here. You may need to draw a altitude. Okay, remember an altitude bisects BC. So basically would create two even parts on BC there. Okay, so let's go ahead and move on to another one. Parallelogram properties and solving for X. Now, if you have a parallelogram, and I'll go ahead and draw one out here for us. Right, if I have a parallelogram, let's kind of look at some of these properties. We looked at the properties yesterday a little bit of a rectangle. Let's look at parallelograms. So here we have opposite sides are congruent. So this side and this side are opposite, so those are congruent. As well as this top and bottom sides are also opposite of each other, so they're congruent. Opposite sides are parallel. So this side is opposite this side, they are parallel. And the top side is opposite the bottom side, so those are also parallel. Realize that consecutive angles are supplementary. Okay, that means that if I take this angle and this angle up here and add them up, okay, let's go ahead and say this is A, and this is B, and this is C, and this is D. If I take angle A plus B, okay, what this is saying here is that angle A plus angle B equals 180. That's what supplementary means, that two angles add up to 180 degrees. And probably the most important part of this, I'm going to do it in orange, is the diagonals bisect each other. So if I have one diagonal here and another diagonal here, bisecting means they create two equal halves, right? So this side of the diagonal, little orange part, is also equal to this little segment. And this little segment on the blue diagonal is equal to the other half of the segment on the blue diagonal. Okay, so you may be given something like, let's say, for example, that this segment right here, that segment is equal to x plus 2. This segment over here may be equal to, let's say, 3x minus 4, right? If those two things are equal and you need to solve for x, we'll just make x plus 2 is equal to this other segment of 3x minus 4. Then you could simply just solve for x. Okay, if I solve for x, then I can substitute it back in and know exactly a number length or measurement of that orange diagonal. And lastly, finding equations of a circle given its center and the point it passes through. So you may be given an equation of a circle with, let's say, a center of, let's say, -1, 4, and it passes through a point. Say it passes through a point, passes through point, let's just make this up. Let's say 2, 5. Okay, now look here, the equation of a circle with HK and radius R. Now the center is at -1, 4. HK is the center. Remember that, center HK. So this right here must be my H, and 4 must be my K. So -1 is H, and K is equal to 4. It passes through a point 2,5. So at this point then, let's change this up a little bit here. I'm going to change this up just because this will kind of give me an awkward circle. So I'm going to say -1. I'm going to change this here, I'm sorry, to 2. And we'll do this to 4 here like that, okay? So now, okay, when I'm looking here, look at this first part. This is the equation of a circle. This is what it looks like. So I'm going to do that x minus h part first. And then square it. I'll just write the whole formula down, or the whole equation. Minus k y minus k, we'll square that, is equal to r squared. Okay, so now I know that my h value is -1. So it's x minus. Now that minus is part of the formula. And h again is -1. And we'll square that. Plus y minus k in this case is 2. So we'll do it like this, and we'll square it, is equal to r squared. Okay, we'll talk about the r part in a little bit. So let's go and simplify this. X minus a -1 is like saying x plus 1, and leave it like this squared, plus y minus 2. There's no simplifying I can do there. I'll just leave it as such, equals r squared. Okay, so if it's passing through a point, and it's passing through this point of 2, 4. So let's say this is 2 right here, and this is 4 here, right? So if it's passing through this point, actually, I'm sorry, that's the center. So the point here, let's say this point in here is 2, and this point here is 4. This is where it's passing through, okay? So then you can do some calculations and say, well, from here, from 4 to the center, what they say 2 here, well, this is 2, right? And we're given that information. Well, from here to here is y minus k. Well, y minus k here, or you could even not even say y minus k. You could literally just count. You have 2 units, right? From here to here, it's like 1, 2. So you have 2 units. Okay? So when we're thinking about a radius, we think from here to here, the whole length, right? Excuse me, from here to here. So if I have, let's say, 2 units here, and x minus h from here to here, I can go ahead and do some calculation there. Okay, well, how far is that from here to here? Right? So then you would do, in this case, 2 squared, 4. Okay, and then let's say this side over here was 3. Right? So then basically, I would say, well, what's 2 squared plus 3 squared equals r squared, right? It sounds like Pythagorean theorem to me, and in fact it is. I'm running out of room here, so I'm just going to kind of do it up here. I'll just come up here with it. And I'll say 2 squared plus 3 squared equals this radius right here, right? This radius is going to equal that. So 2 times 2 is 4. And 3 times 3 is 9. So this equals 4. And this 3 squared equals 9. 4 plus 9 is 13. So the final answer here, to put in right here in this one part that I'm missing of the formula, is equal to r squared. So this equal to 13. Okay? So be aware of that as well. I'm going to go ahead and upload this video now to a YouTube link, and you'll have it here momentarily. Good luck, everybody. If you have questions again, I'll be available until 8 p.m. tonight to field questions as you study through this. There's a video available from yesterday that we had in class, and a video available from today's class recording. This here is a YouTube video to touch on the few questions or few slides that we didn't get to cover in class today. Okie dokie. Good luck.